Dear students, today I will teach you factors affecting the molar conductance. It is another chapter, another portion of electrochemistry. So what are the factors? First point, nature of electrolyte. Second point, concentration of the solution. Third point, temperature. In ODIA, को फैक्टर मोलार कंडक्टेंस को प्रभाव करुछि गोटे होची नेचर ऑफ इलेक्ट्रोलाइट सेकेंड होची कंसंट्रेशन ऑफ द सॉल्यूशन रो कंसंट्रेशन केमिति होची डाइल्यूट होची ना कंसंट्रेशन होची थर्ड होची टेम्परेचर तापमात्रा देन नेचर ऑफ इलेक्ट्रोलाइट हाउ इट इज अफेक्टिंग स्ट्रॉन्ग इलेक्ट्रोलाइट्स as dissociates completely hence have high conductances जेहेतु strong electrolyte complete dissociate हो जाउची तेणु सेमानकर conductivity अधिक second as weak electrolyte dissociates partially weak electrolytes like ammonium chloride ammonium hydroxide acetic acid these are dissociates partially partial means suppose 5 grams you take then out of 5 gram only 0.2 or 0.3 gram will be dissociate so weak electrolyte dissociate जोटा दुर्बल इलेक्ट्रोलाइट से dissociate कौन करछंदी partial माने पूरा पूरी dissociate हो नांती तो सेमानकर कंडक्टेंस टा कम रहबो नेक्स्ट कंसंट्रेशन ऑफ द सॉल्यूशन रो कंसंट्रेशन how it affects केमिति प्रभाव पकोची concentration means गोटे होची पूरा concentrated हेतिबो नहले dilute हेतिबो the molar conductance increases with decrease in concentration जदि आमे dilute अधिक करिवा पानी ऐड करिवा बा जे कोने solvent अधिक ऐड करिवा ताले से dilute हे जिवो dilute हेले तार molar conductance increase होबो मोलार कंडक्टेंस इंक्रीजेस विथ डाइल्यूशन कहीं ना आमे बहुत गुडे आयन से पाइबा वीक इलेक्ट्रोलाइट में एटा बेसी हेल्पफुल स्ट्रॉन्ग इलेक्ट्रोलाइट तो स्ट्रॉन्ग इलेक्ट्रोलाइट जेति डिसोसिएट होबा कथा डिसोसिएट हे जिवो एंड वीक इलेक्ट्रोलाइट पई एडी डाइल्यूशन आमे कले बेसी आमे कंडक्टिंग पावर टा बढ़िबो देन टेम्परेचर with increase in temperature the conductance of an electrolyte increases whenever you increase temperature the conductance increases temperature बढ़ेले conducting power टा electrolyte रो बढ़िबो next is Kohler's law एटा गोटे electrochemistry गोटे law at infinite dilution what do you mean by infinite dilution means if you add more solvent that is known as infinite dilution what will happen each ion makes a definite contribution each ion at infinite dilution each ion makes a definite contribution towards molar conductance of the electrolyte irrespective of the nature of the other ion with which it is associated suppose you take HCl so whenever you take HCl and put inside water the conducting power of H plus and the conducting power of Cl minus both are counted towards the conducting power of HCl. Understand? Next portion is the molar conductance of the electrolyte can express as the sum of the concentrations of the cations and anions at infinite dilution. Means whenever you want to calculate the conducting power molar conductance of an electrolyte at that time you have to take the conducting power of the cations and adding with the conducting power of the anions okay in ODIA Kohler's law कौन ना जिते बेले हम गोटे इलेक्ट्रोलाइट नौचंदी तार कंडक्टिंग पावर कौन तार कंडक्ट मोलार कंडक्टेंस केते ना से तार मोलार कंडक्टेंस होची ता भितर थिबा कैटायन मानकर कंडक्टिंग पावर प्लस एनायन मानकर कंडक्टिंग पावर दुईटी मिसिले जहा हबो सेटा होची मोलार कंडक्टेंस ऑफ द इलेक्ट्रोलाइट So here is mathematically it is expressed, the molar conductance of the electrolyte is equal to molar conductance of the cations and the molar conductance of the anions. Then what is the application of Kohler's law? Kohler's law ro application कौन कोड एटा दरकार पड़ची. First point, calculation of the molar conductance at infinite dilution for weak electrolyte. Here is the weak electrolyte ammonium hydroxide. How it is calculated? By taking the molar conductance of the ammonium chloride, adding with molar conductance of sodium hydroxide, and from this addition you have to subtract the molar conductance of the sodium chloride. So here what will happen? Na cancel and Cl will cancel and you will get NH4 plus and OH minus, that is ammonium hydroxide. So this is one application. Second, calculation of degree of dissociation. Degree of dissociation, what is degree of dissociation? The amount you put in what solvent, and out of the amount, how much the amount it dissociates. The ratio is known as degree of dissociation. Okay. So calculation of degree of dissociation कौन ना degree of dissociation होची तमे केते इलेक्ट्रोलाइट नेलो से पानी रे पकेलो बा सॉल्वेंट रे पकेलो सेथरो केते परिमाण डिसोसिएट हला केते परिमाण आयन रे परिणत हला, that is known as degree of dissociation. So weak electrolyte पई degree of dissociation ना सब बळे गोटे भग्नांश. For weak electrolytes the degree of dissociation is always a fraction. For strong electrolytes, the degree of dissociation is always unit 1. Why? Because how much you take, all are dissociated into ions. Therefore, for strong electrolytes, the degree of dissociation is unity. For weak electrolytes, it is a fraction. Then what is dissociation constant? This is dissociation constant. It is related with the concentration and degree of dissociation. So this is the relation. Why 1 minus alpha is taken as 1? Because for weak electrolytes, say suppose you take here 5. So out of 5 you dissociate less very amount, say 0.2. So 5 minus 0.2 is how much? 4.8. So 4.8 you can take as a 5. That is why 1 minus alpha is taken as 1. So the relation is Kc is equal to C alpha square. So from this, by using this relation, you can solve the problems. Next is, you have to do a problem. Electrolytes like potassium chloride, potassium nitrate, HCl, sodium acetate, NaCl, these are the different electrolytes given, and their molar conductances are given. Okay. So by using these values, you have to calculate the equivalent conductance of the acetic acid. So out of these 5, you have to take only 3 because other 2s are not requiring. So what are the values you have to take? You have to take the CH3. You have to take CH3CONa, sodium acetate, and HCl and NaCl. You put these two values, add these two values, that is 91, and for HCl 426.2. You add these two values, and from this addition you have to subtract the NaCl value. Then you will get this answer 390.7. Okay. Next is, what is electrochemical cell? What is electrochemical cell or galvanic cell? It is an electrochemical device. It is a device, electrochemical device. What is its function? It converts chemical energy into electrical energy. So in this cell, oxidation and reduction both occurs in separate containers. The separate containers are called the half cells. Okay, इलेक्ट्रोकेमिकल सेल कौन गाल्वानिक सेल कौन ना एटा गोटे डिवाइस बा सर्किट कहते जो थी कि ऑक्सीडेशन हम रिडक्शन हम एवं से केमिकल एनर्जीटा इलेक्ट्रिकल एनर्जी रे परिणत हम. सो व्हाट इज द ऑक्सीडेशन लेट अस से जिंक सल्फेट रे आम जिंक नेले जिंक सल्फेट सॉल्यूशन रे आम जिंक रड गोटे पकई कॉपर सल्फेट सॉल्यूशन रे कॉपर रड गोटे पकेले यू पुट जिंक rod in zinc sulfate solution and copper in copper sulfate solution. Then these two solutions are connected through a bridge. This bridge is made up of salt. Therefore, it is known as salt bridge. तेटा ना होची salt bridge. What is the function of salt bridge? A salt bridge रो काम कौन? The function of salt bridge is complete the circuit. If there is no salt bridge, it is salt bridge is not thanda. ताल कौन होता then the circuit will not be complete because the electrons flow from anode to cathode. This is anode to cathode. Electron एटी पळे आसला but electrons are not transferring here. So therefore there is the requirement of the salt bridge. What is the another function? It also maintains the electrical neutrality up to half cells. इलेक्ट्रिकल न्यूट्रालिटी इलेक्ट्रॉन फ्लो हेले ही न्यूट्रालिटी आसीबो प्लस टा न्यूट्रल हबो माइनस टा भी न्यूट्रल हबो. सो दिस इज द वे ऑफ मेंटेनिंग इलेक्ट्रिकल न्यूट्रलिटी. सो हाउ कैन यू रिप्रेजेंट सिंबॉलिकली दिस इलेक्ट्रोकेमिकल सेल? सो दिस इज द वे ऑफ मेंटेनिंग जिंक इन Zn+2 1 molar solution. This is your salt bridge. जो दीटा गारो दिखाई दीटा लाइन दिखाई एटा हूँ सॉल्ट ब्रिज रो रिप्रेजेंटेशन. देन Cu+2 in 1 molar solution and this is Cu. So here what happen? Zinc to Zn+2 means loss of electron, therefore it is oxidation half cell. एटी कौन है? what will happen here? Cu+2 आर जो इलेक्ट्रॉन आसला से दीटा नहीं कि Cu है, therefore this is reduction half cell. Then what is electrochemical electrode potential and EMF of a galvanic cell? So we know whenever we put zinc in zinc sulfate solution, there are three things will be happen. Chances of happening three things. What? Either this zinc rod will lose its mass, first point. Second point, or the zinc rod will gain its mass. Third point, it will remain neutral, no loss and no gain. So that means there is a difference between the zinc rod and the solution, zinc sulfate solution. So this difference in potential is known as the potential difference. So due to the separation of charges between the electrode and the solution, an electric potential is set up between metal electrode and its solution is known as electrode potential. This electrode potential रो आउ गोटे ना अच्छी ताकू EMF electromotive force कहते. So potential difference between two electrodes when no current flows in the circuit. When there is no current flow, then it is known as EMF. When there is current flow, that means the circuit is closed, then there is a flow of current and it is known as potential difference. Therefore here in the EMF it is maximum voltage obtained from the cell. Here it is less than the maximum voltage obtained from the cell. So electrode potential is represented E cell is equal to E reduction minus E oxidation. So you can take here Zn, your copper is the reduction and zinc is the oxidation. So copper and zinc example you can take. Then what is electrochemical series? Electrochemical series कौन? Now it is the series of arrangement of elements in the decreasing order of their reactivity. Another way you can also say the arrangement of electrodes, that means elements, in the increasing order of their standard reduction potential values is called the electrochemical series. So what I told in the first, that is the decreasing order of reactivity of the metals. It is easy to understand, it is easy also to remember. So you take hydrogen as the standard. So above hydrogen, these are highly reactive elements, and below hydrogen, these are less reactive elements. Okay. So the reduction potential value of these elements are highly negative, then gradually the negative value decreases and going towards the positive value. So these are giving the positive values, positive reduction potential. So then what is the necessary of the electrochemical series? First point, the negative value of electrode reduction potential metals can displace the positive reduction potential value metals. That means you can take zinc. Zinc can displace the copper, but copper cannot displace zinc. Second, these elements are highly reactive. These metals are highly reactive. Third, these can displace hydrogen from the acids. These metals can displace hydrogen when reacts with acid. Say zinc plus H2SO4, then is release of hydrogen gas. But if you take copper with H2SO4, you cannot replace hydrogen from the sulfuric acid. Okay.